everyone. Happy Math Crush Monday. I apologize for those of you who are right on time. We are running just a few minutes behind today, but I am excited to be with you. My name is Shannon Keebler. For those of you who don't know who I am, I'm the moderator of this group. And tonight we are talking about area and perimeter. So the standard progression actually begins in second grade. That's really when we first start talking about area and perimeter, and where the learning progression starts. Second grade starts with it in terms of building arrays, and they struggle with understanding that there can be no gaps when we find the area, when we push those squares together, that each one of the squares is of equal size, that we use units, right? So we start that type of thinking in second grade, and then we get into third grade and the progressions really picks up, and we take it all the way through. I mean, upper levels of geometry, everything is connected now back to the work we're doing in second and in third grade. So it's a topic that comes up a lot. It tends to be one that students mix up a lot. They mix up the terms area and perimeter. They forget which one they're trying to find. So I wanted to address that a little bit tonight, and then answer any questions you might have. I know a third grade teacher said that they struggle with finding unknown side lengths, okay, which is really about understanding numbers and the shape in general. But if I know one of the parallel sides of a rectangle or a square, then I should be able to know automatically that parallel side. That I might have to recognize that if I have area and I know one side length, that I'm going to use division to find the unknown side length, right? But all of that, regardless, comes back to understanding what it really means to have area and perimeter. And so I want to share my screen tonight and just share with you a few things that I think will really help, regardless of the grade you teach. Okay, so if you teach third grade, fourth grade, or fifth grade, even sixth grade, as you get into more complex figures, all of this builds on itself, and you may have to take a step back in order for you to go forward, right? Make sure that students have conceptual understanding of what area and perimeter are. So I'm going to share my screen here. If you're watching, tuning in, let me know what grade you're teaching, what questions you might have about area and perimeter. Maybe let me know something that your kids struggle with specifically. I'm happy to try to answer that tonight. If you're watching the replay, let me know. Just show something on the post. It sure is helpful to know people are watching, and that I should keep doing this. Okay, so it's nice to know you're not talking to yourself. So here we have, let's share my screen here. Let's see if we can do that. There we go. Okay, so here's what we have. The first thing we have is we talk about perimeter, or actually we'll talk about area first, but let me, yeah, I think we might be able to do that. Let's talk about area first. So this is just a random slide that I have created for our Math Genius Squad members, and they have these square tiles. And the idea is that we're trying to create this, this space for this dog, right? This playpen. And we're trying to figure out how many 1 unit squares fill up this space where there are no gaps and there are no overlapping square tiles. So this would be an example of when we talk about building a concept CRA, right? And C being concrete. We want to have kids give a concrete experience. So the slide here is showing these square tiles, and kids can be assigned a Google slide or a Jamboard, and they're trying to figure out how many of these squares are going to go on the inside. But in a physical classroom, I mean, of course, they could use a technology, but I would give them square unit tiles. So these square tiles, they come in second grade. So if you don't have any, borrow some from your second grade teacher friends, because they have them because they build arrays with them. And they come in their math expressions kit. But if you don't have them, you're going to want to grab these, right? They're really inexpensive, a container on Amazon, but put that on your wish list for your school leader for the next year, because they're really foundational in what third grade does in learning multiplication and division, doing equal groups, area, array. All of those are coming together and fit in here. But when we think about CRA, C is that concrete. So we want to give kids a concrete experience of filling in a shape, whether it's their desk, whether it's the their math book, whether it's a predetermined square or a die cut square that you've given them, or rectangle. Okay, so we want to give them square tiles to fill this space, right? So that's the goal. So we're going to fill it up so we can say that you just found the area of this rectangle. We're looking for the space inside. Okay, so if I come here, I want to show you my visual is area. You can see these square tiles inside. This would be the R, the representation, because what I want them to do is I want them actually to connect on either centimeter grid paper or even better on dot array. Okay, so again, 3rd and 4th grade, this is very much applicable to you. We want students to understand the difference between area and perimeter, and they have to see the squares inside. So if you look closely at the standard says that students in 3rd grade are just learning conceptually what it means to find area, and then they will make the connection to multiplication and division. But their standard is not the formula. That's not their standard. 4th grade, your standard is generalized to a formula. Okay, but if we rob students in both 3rd and 4th grade and in 5th grade, actually, when we get into the fractional units, of the opportunity to see square units, then we're forcing them to rely on a mnemonic. We're forcing them to rely on a formula or to just really a short-term something to remember, oh, this is just what I apply in this situation versus falling back on what I understand about what area and perimeter are. So anytime we give kids a concrete experience and then we give them a visual representational, right? If I come here, okay, if I go to our representational experience, I'm able to anchor back to that experience when I'm like, shoot, area, which one was that again? Okay, so here, watch here. If I said that I was doing perimeter, perimeter is the units or the length of units. It is a length model. So I'm going to use color coding on my dot array side. So you can use it on your whiteboard. You need the fine tip expo markers or just go to your teacher resource book. It's a black line master book. It has dot array paper in it. You can just Google on the internet, you find dot array paper. But you want kids to use colors. Okay, so I go from here to here, that's 1 unit. I have traveled 1 unit. So 2nd grade, you know this because you introduced the ruler and you know that you were introducing these lengths that I do not get to say I traveled anywhere until I've gone from here to here. Now I've gone 1. So we don't count tick marks. We don't say 1, 2. We say 1, and now this was 1 unit. 4th and 5th grade, that happens to you when you're talking about finding those fractions on a number line, okay, right? We loop those fractions because we're looping lengths. That length idea comes back here. This is 1 length. So I'm going to use color coding to go every other color so that students are focusing on the lengths, not on the dots. Right? So if I'm using centimeter grid paper, I'm going to trace the lengths from one side of the box to the next side of the box. So if I go here, and you can see my paper in there. Okay, I'm going to go from, let's see if I can get the right pen here. From here to here is 1. Okay, from here to here is 2. But I'm going to go color coding because I need students to understand the difference, okay, of a length model. So when I talk about perimeter, I'm just going to go back and forth here with colors. There we go. We're going to go, there we go, from here to here, next color. Okay, from here to here, how many lengths have you counted? And this is when you start to see that they have, you know, a shape like this and they have those tick marks on it. You still have to have kids loop the lengths because they don't see them. They see tick marks. They don't see lengths. So if you give them just a general, you know, square like this, and then we show them those tick marks, it's just like the ruler. They start counting the tick marks. Well, that's not perimeter. Perimeter is a length model. We're counting these lengths. So I want them to loop or trace each length. If I do it with colors, more often than not, kids are going to see it way more clearly. Okay, so remember, perimeter is all the way around. We add up the sides because I need now a gate for that little, you know, puppy area that we were talking about. And so I want to know how many lengths, how many unit lengths there are all the way around that figure. And now in 3rd grade, I'm going to have to capitalize on the idea of understanding shapes enough to know that I have parallel sides that are equivalent. Okay, 2 sets of parallel sides, so that I can figure out unknown side lengths, right? But I think the color coding and the dots are going to be key for you all. So I'm going to just, for sake of time, I'm going to go ahead and finish this guy. Okay, and let's just say that we went all the way up here. So now we have this shape. I went every other one and I went, you know, red, blue, red, blue. So just pretend I did that. Okay, but now I'm going to have kids connect the dots And you're like, that's going to take forever. And then I'm going to say, I know, but remember, when it's painful, it's permanent. Okay. So when I make them do it, they're never going to forget. And I'm going to say, do you see squares now? Yeah, well, we used our square tiles, and we created different size rectangles using the tiles, and we counted all the tiles inside and we said, that's the area. Okay, I'm going to move them to the dot paper to find the perimeter. Then I'll take them back to the tiles to work on perimeter, but it's harder to see. Like if I use all red tiles, it's harder to see the lengths of units because it looks like one continuous line. Right? So at least I'm going to have them vary, you know, like every other row is going to be something like this. Okay. So in third grade, now we're going to count the squares inside. We want to know the amount of space that is taken up. So let's jump real quick to fifth grade. When fourth grade does equivalent fractions, we say that those fractions are equivalent because they have the same area. Okay, all of these words connect and all of these topics are interchangeable if we understand how they connect, right? So I can say, I know that 1/2 and 2/4 are equivalent. And with some people are like, well, because it's the same, or because I can simplify one to make the others, or I can multiply one to get the other. No, it's because they have the same area. Even if they don't have the same size and the same shape, if I cut them all up and put them inside of each other, they would take up the same amount of space. Okay, so area has the same amount of space that is being taken up. That's the space inside. So when I have third through fifth graders first learning this, right, we're going to go all the way around the outside and we're going to say it as we go. Perimeter is all the way around. We add up the sides. And then we say we measure in lengths of units, okay, or in unit lengths. Then we talk about, okay, the inside, I want you to take a different color now, and I want you to shade the inside, and I want you to say the area is the squares we count inside. Do it again. Area is the squares we count inside. I want to cover that whole space. And I'm going to say, well, how are you going to count those squares? Okay. Now, third grade must see the squares. I know the book takes you to abstract rectangles and math expressions, rightfully so, because they should make the connection to area or to multiplication and addition. But so many of our kids didn't really get that back in unit 1, right? They didn't really understand it. And this is their connecting piece to that standard. We're trying to get them to say, how can you count those squares inside? Now, a third grader should be able to say, well, it's 1, 2, 3, 4, and they can actually count them all. I'm like, there's got to be another way, right? So they go 4, 5, 6, 7, 8, 9. Like, well, I knew that it was 9 in this row, and then there was 9 in this row. So I had 2 9s. It's 18. Right. That meets the standard that says that they understand area as additive. Okay. So there you go. I have 2 rows of 9. I have 18 squares. You're right. I don't have to count them one by one anymore. And someone else says, well, no, I just did 2 times 9. And I'll say, well, how did you know to do 2 times 9? And they said, because I see 2 rows and they each have 9. Okay, or someone's like, well, I did 9 times 2. Where do you see 9 times 2? They're like, well, I saw, well, because look, there's 9 columns. Show me 1, 2, 3, and they're showing me the columns, and there's 2 in each. Remember, multiplication is equal groups, 2 groups of 9 or 9 groups of 2. But I have been in so many third grade classrooms where they just know the equation and they don't see it for their life because someone taught them an equation or a formula too soon. And now they're just like, oh, you just do multiplication for area. But then when it gets more complex, which I'm going to show you in 5th grade, and it's fractional values, they can't say perimeter from area. They can't remember which is which. Okay, because they never had the conceptual experience, that concrete experience. So in 3rd grade, it's about seeing rows and columns. I need them to see that area is the inside, and there are sophisticated ways of counting the inside. So we're really just saying, well, how else can I count the inside? How else can I count the inside? They start to realize that when I say 2 times 9, I'm not saying length times width. Say it again for the people in the back. I'm not saying the length times the width. That's 4th grade standard. 3rd grade, I'm saying I see 2 rows of 9. I'm focused on the columns and the row language in 3rd grade. Okay. Then, so they're going to, of course, they're going to generalize. We're like, well, it's just 2 times 9. Right. So then we are able to take them to something that looks more like this. And then we can show them, right? So here I am, and now I can just say, well, let's just say that this was 3 and this was 7, okay? But if kids didn't have the other experience, I would say fill it in, prove that to be true. Like, well, you just do 3 times 7. Why? Okay, because it should be 3 rows and 7 columns. That if I count all those squares, I'm going to get 21. It's not just because 3 times 7 equals 21. It's because if I actually make those squares, those length of units on each side, on the length and the width side, I would get, and I connected all the dots, I would get 21 square units. If there's a reason that it works, I'm not trying to just memorize a formula. Okay, now when I get to 4th grade, we're saying that it's length times width. Okay, so and we're having kids prove that. Then we're saying, well, perimeter is, what is perimeter? And they can say, well, it's 2 times L and 2 times W. Okay, and we're going to add those together. Or they can say it's L plus, sorry about that, terrible handwriting, L plus W plus W. But 4th grade standard is them figuring out formulas that would work and that they can prove would work every single time when we talk about a rectangle. Okay, so I'm going to show you a couple more things here. Let me pause for a moment. I want you to put in the chat something you've heard that you're like, I'm going to try that, or I do that, it works. Something affirming, confirming, question, put something in the chat you're thinking right now, reiterate it to the rest of our friends, and let me check out what's going on in our chat here. They had to tell the greatest area possible of the figure. So they were given 2 side lengths. They were given all the side lengths, I'm assuming, Melanie. They had to tell the greatest area. So that's actually something that they will only be able to do if you give them those concrete experiences earlier in the unit, where if you look at my small group activity, specifically in the Math Genius Squad, we'll say here's 12 square tiles. What are all the different combinations of rectangles you can make? Or it has a side of 3 and 5. What's the greatest area you might be able to make, okay, of one figure? Because they should know that if it's a rectangle and it's 3 and 5 are the side lengths, right, then I should have 15 is the greatest area I can have there. Let me know if I'm not understanding your question right, but that is a part of that explore of, I can't just count what I see in with square tiles. I have to also be given the opposite question of, what if I gave you 15 square tiles? What are all the different rectangles? And what is maybe the largest side length of a rectangle, which would be a 1 by 15. Okay, they have to see that different shapes can have the same area, but have different perimeters. And that's like mind blowing. See if that helps. Do kids need to place fractions more than 1 with different denominators on a number line? Yes. I don't know for MCAs. I'm going to guess yes, because Minnesota standards are just even a step above Common Core standards. And Common Core standards are absolutely, they have to be able to place multiple fractions with, I think it's only 2, maybe halves, thirds, fourths, maybe even 6 in there. But yes, they have to place different denominators on the same number line. Yeah, Nicole, see if you can tell me more about that, Melanie, about that question, or give me the question in your book and I can go look it up and we can talk more about it, okay? All right, so now I want to show you, share my screen there. Okay, so here's some other things that you can remember. So I put up this anchor chart. Okay, if you want this anchor chart, Math Genius Squad members, you already have it in your units. You can go grab it. Perimeter, same thing. If you just want them delivered to you, just say me in the chat. Give me an email or tell me to put it in your DMs or whatever, but you got to say me down below and I will send those to you. So this is the area, the anchor chart that I put up, and we just say everyday area is the squares we count inside. Hey, we talk about it being square units. Why is it a square unit? It's 1 unit long on each side. Okay, that's important because guess where we're going? Volume. Okay, and they have to know cubics, a square unit size and 1 unit side in order for us to get to cubics. Okay, so cubic units. So now we have area. So this is how the visual I give kids to remember. I'm going to let them use grid paper for as long as it takes. Okay, if I notice that kids just start applying formulas and they can't tell me why it's 21 other than it's multiplication, then I'm going to make them go do it on a grid paper. I need them to see the squares inside so they do not forget. But this visual should help them. Then when we see perimeter, we always say perimeter is all the way around. We add up the sides. Okay, so all the way around, the distance around an object. So you can see that we know that Perry means around and then We can talk about it being around this area, okay, a measurement meter being measurement. And so we can go all the way around. That's another visual, okay, so you can see the word perimeter isn't the same as the word as the tracing around the object, okay. And then here's what I do. Every time in the book that they see those words, they have to go find the words and shade them correctly. Okay, so let's just say they get to a story problem and it says, John wants to know, how much fencing he needs to find, the perimeter of his backyard. I'm like, did anyone see a word or words that tell them that we're doing the distance around an object? And they'll go find it in the directions or in the story problem, and they will say it and do it as they go around. Perimeter is all the way around. Every time they see that word, they're going to do that. Okay, and then I'm going to say every time you see the word area, I want you to shade over it. So let's just say it's reading, it says, what is the area of a rectangle that has, and it says something about area. Okay, so let's just say that this says area in my directions. I'm going to lightly, okay, we're not going cray cray, but we're going to lightly with our pencil, we're going to shade over it, and we're going to say area is the squares we count inside. This is the space inside, and we're going to do it every single time we see it. Okay, now what's going to happen is we're going to also get rectilinear figures. Okay, so this happens in 3rd grade where they have 2 different rectangles. This is the additive, an additional part of the additive part of our standard. The students need to be able to decompose shapes into 2 separate shapes, 2 or more separate rectangles, find the separate units of each and then add them together. Okay, so it's like the distributive property that we did early on. So we want kids, again, the best way to do this is on dot array paper and to do color. Okay, trace the 2 different shapes that you see. Where do you see 2 rectangles? And kids see them differently, right? So have them trace what they see and then have them use different colors and go every other to show us that perimeter or that area. Okay, so I'm going to find that perimeter all the way around, and I'm going to find my area. So I hope I see area, shade over it. This means area. If it was a pencil, you could still see the word. Perimeter is all the way around. We add up the sides. So now here's what happens. So now we get into 5th grade. So 4th grade, you're doing all that work as well. Okay, we get here. Let me tell you about this one really quickly. So if you're here, you'll see this is why you cannot skip the area and perimeter quick practices. So 3rd grade, this is all of Unit 7. Unit 7 is all day long, all the different scenarios of I gave you the area and I only gave you a side length. How do you find the other side length? Okay, so we're going to be rehearsing those complex shapes over and over and over again in Unit 7. So if they didn't do well with something on that Unit 5 test, let it go and know that they're going to get a lot of repetition here in Unit 7 because we know they're not procedurally fluent. They just built the concept. They have to build fluency in identifying, wait a minute, if I have the area and a side length, I'm going to do division. Okay, and so again, squares inside, if you see the centimeter grade, it's going to help them understand that. But now we're saying, okay, we've done it so much, they should be able to just see a rectangle or a square and be able to figure that out without the squares inside. Not everyone, but some. So if they're not able to, you're going to take and you're going to draw that in, right? Have that student leader, whoever's the student leaders for that quick practice, draw them in and say, we know there's 54. How many columns would I need? That should jog them. Oh, that's division. Okay, so just keep that in mind that this is all, it all comes back. So if you're skipping quick practice, friends, knock it off, bring it back. Okay, it is going to provide the practice that we know they need. Okay, last one here. I'm just going to bring this up quickly for time. 5th grade all comes back to you, but I want you to notice, okay, woohoo, look what happens. Now it's fractional units. Okay, so things just got real hairy. Okay, so now we're taking one of those squares over here. Watch this. We're going over here and we're taking that square and we're saying, if I took that square and I broke it up, what would it be like now? Okay, so I took a single square and I broke it up into more square units. And I'm only shading part of the square units of a single unit. Holy macaroni. Okay, so now I'm taking a fraction of a fraction, right? So my answer has to get smaller. So I'm in fractional multiplication, but I want them to see that it's of a unit and how much color coding helps. So I can count this. I have 1, 2, 3, 4, 5, 6, 7, 8 out of 9, 10, 11, 12, 13, 14, 15. I should have an answer of 8/15. Do I get that when I do 2/3 times 4/5 when I'm finding the area? Right? And I do, I get 8/15. But students have to conceptually understand that I took one of those square units and I'm breaking that into additional square units and I'm only shading part of it. Okay, it's so complex for them. And it is really complex if we didn't do our work in 3rd and 4th grade with graph paper and with dot arrays. If we skip that too quickly, then 5th grade, they're really just relying on formulas, right? And then we get into tangrams and we get into finding the area of shapes that are not rectilinear, and we have triangles and all sorts of other things that start happening in 6th grade. Okay, it all fits together. So if we skip even the geometry standards in 3rd grade and 4th grade of playing with tangrams and figuring out what shapes, that comes back to 1st and 2nd grade also, kindergarten, what shapes make up other polygons, that all relates back to what we're going to do in area. Okay, understanding that keeps connecting all the way through, because now we have to find the area of a triangle, right? But I first have to know that that equilateral triangle makes up a hexagon, and there's 8 of those. I'm telling you, friends, okay, it keeps building, right? So I know geometry is one of the things that we all like barely get to, but this is a good indication or good reminder of how important it is that we still slow our roll and we allow kids to build the concept fully. Okay, so if we have more comments, I apologize. They're not loading right now on my screen, so I'll go back and answer those, but put something in the chat. Let me know if something was helpful to you. If you'd like those anchor charts, I'm happy to give it to you. Remember, if you're in my Math Genius squad, I'm going to do videos like this for every lesson. So I will help walk you through the unit and the lessons so that you understand how to teach them and what visuals or what other cues you might be able to give your students to help them out. If you're in my Math Genius squad and you get questions like Melanie's question about that test item that was really tough, you can always go put those in our private Math Genius group, Facebook group, and I would be happy to talk through those more with those members to help your kids get better at those, if I can help you find a solution. All right, so happy Math Crush Monday, everyone. It's such a joy to see you all. Happy spring. I'm so excited that spring is here, and we will see you all next week. Let me know in the comments if there's something else you want to talk about, another standard, and we'll see you all very soon. Take care.